dual nature of electron. This topic we will see in this video. Actually, the dual nature of electron proposed by there is a D. Broglie. Okay, there is a D. Broglie. He is proposed the dual nature of electron. He is based on that Einstein theory as well as the Planck theory. There is Einstein theory, as well as there's a Planck theory. So this both theory is based on that whenever a particle behaves or whenever a matter behaves for both particle as well as the wave nature. So that is nothing but that is a dual character. Okay, the according to Einstein, that all particles can be behaves like a wave as well as a particle like a nature. There is a all matter or all matter or all particles behaves as a there is a wave nature as well as there is a particle nature. So there is nothing but there is for dual character. These two is nothing but there is a dual nature. Okay, so whenever a matter behaves as a particle as well as there is a wave nature, then the wave mechanical theory of matter, according to this theory, the electrons, protons, even atoms, when motion possesses a wave properties. Okay, so in generally there is a the mass inversely proportional of that is a wave nature. Okay, inversely proportional of that is a wave nature, because for example, see, we throw out a stone. That's nothing but this stone. This stone we can to throw out this point. So it's moved to the straight line. Some depends on that gravity force and applying the external applying the force based on that the have moved to the straight line, or there is a parabola line. Okay, so mostly there is moved to the straight line, or if you assume as a the bullet, that bullet as a move to the straight line. Okay, okay, so whenever that mass as increases, the wave nature or decreases. And suppose, see the leaf, there is leaf, this leaf actually there is a fall from the top of the tree. So this move towards almost there is a wave nature, because this leaf as a weightless or mass is a very less. So for example, this is a top of that tree, it's a bottom of the tree. Okay, this is a bottom of the tree, it's a top of the tree. So here the top to bottom falling the leaf is like of wave nature. Okay, so because in between this air is there, so they have restricting that is cannot fall on the straight line motion. So it's more fall on that wave nature. So that's why we can compare the stone as well as leaf, this leaf as a weightless and compared to the stone. Okay, so that's why the mass is decreases, wave nature increases. See, in the case of atom that's consisting, there's three subatomic particles, that's electron and a proton as well as a neutron. Okay, so we know that initially this electron, proton, neutron, here there is a mass as a there is neutron around almost equal to of proton, but there is electron as very lesser mass. See, there is a almost very less mass it consisting the atom such as electron. So this electron can be revolving around the nucleus. This is a nucleus, it is a orbit. Okay, this orbit is consisting the electron, and this nucleus is consisting as a neutron as well as a proton. That's why the entire atomic mass is equal to for the sum of the nucleons, the sum of the neutron as well as proton, that is equal to for mass number, but they are not consisting as a electronic mass. Okay, so the electron of mass is a very negligible, so it consisting as a dual character. Okay, as we go to that, the Planck theory equation, there's a Planck equation, there is a E is equal to h nu. Okay, so this energy is frequency, it's a Planck constant, h is a Planck constant, and we know that nu frequency nu is equal to c by lambda. Okay, so this nu value go to substitute here, there's a E is equal to h c by lambda. Okay, okay, so this is one of the formula. And the second theory, that's Einstein theory, Einstein equation. Einstein equation, we most familiar, there is a E is equal to mc squared. Okay, so E is equal to mc squared. Now we can go to that, substitute or correlate this Planck equation as well as Einstein equation. We can get that is a h nu is equal to mc squared. So we know that there is a nu is equal to c by lambda. So that's why there is hc by lambda is equal to mc squared. So now this c and c squared is cancelled out, remaining what? Remaining actually there is a h by lambda is equal to, that is mc. Okay, so now this h will comes there. So 1 by lambda is equal to hc by mc by h. So we need to lambda what we can get as h by mc. Okay, so this is one of the formula for the de Broglie equation. So here the m as a mass of electron, h as a Planck constant, lambda as a wavelength, c as a velocity. Okay, velocity of light. We know the velocity of light, that is equal to 3 into 10 to the power of 8 meter per second. And also Planck constant value, that is everything is we know already. We can go to that, substitute all data, we can finding the value of lambda or wavelength. Okay, so now we can go to that the particle, or there is a the particle velocity or light velocity, there is a 3 into 10 to the power of 8 meter per second. There's a particle velocity, that is c is relating to nu. So we can go to that, lambda is equal to h by mv. Here the mass into velocity, actually this is one of the formula, and also the mass into velocity is equal to for momentum. So we can exchange this mv into p. So lambda is equal to h by p. So this is the final formula. So whatever that, those three formulas is very very important for most basic of the de Broglie equation. Next we can get in that different formula from this formula. Okay, there is a lambda, actually there is a lambda is equal to h by p. From this formula we can get in, there is a different formula. There is a one as lambda is equal to h by mv, and there is a another one formula, there is a lambda is equal to h by, there is a root of 2m, there is kinetic energy, and there is another one, that is lambda is equal to h by root of 2m, that's a qv. Okay, so this four formula is very very important. Okay, so now let's we go to that, there is a relating the angular momentum. So we know that angular momentum, that is mvr, that is equal to n h cross, or h cross is equal to h by 2 pi. So that's why here there is a mvr is equal to n h by 2 pi. This is the formula. Here n as a principal quantum number, so depends on that this angular momentum value are rearranged. Okay, so we can correlating this formula, we can get there is a h by lambda into r is equal to nh by 2 pi. Okay, we know here there is lambda is equal to, here h as a cancel out, then r is come to divided, that is why there is 1 by lambda is equal to n divided by 2 pi r. Okay, so that's why here there is a lambda, what lambda, yes, lambda is equal to, that is inverted, that's 2 by r divided by n. Okay, so this is a very important in the de Broglie equation. Actually this is a somewhat is a advanced level. Okay, so basically there is a de Broglie equation. This four formulas is essential for calculating the NEET and JEE level problems. Yes, student, next topic there is a Heisenberg uncertainty principle. This is a very easy, very smallest topic. This Heisenberg uncertainty principle, actually there's very small particle, very smallest or very small particle, that's particle cannot be measurable, or cannot be measured, both cannot be measured simultaneously, or there is simultaneously or both, there is simultaneously, both position as well as momentum, position as well as momentum. Okay, so simply what it's saying, very smallest particle cannot be measured simultaneously, both position as well as momentum. Okay, because we know that the atom, this atom center, there is a nucleus, it's consisting as a neutron as well as proton. This orbit is consisting the electron. There is very smallest of these three fundamental particle. Among these three, this electron is very very small. Okay, because there is a very very lesser mass also. So these electrons can be revolving around the nucleus. So whatever that, the position or momentum p is equal to mv. Okay, the particular mass of this particle, velocity, there is when it's a move, velocity is nothing but the displacement from one point to another. So there is the whenever this electron is move or rotating in this path, we can finding the momentum. But during the motion, we cannot say whether the electron is here or here or here or here. So like that, we cannot say exactly that position. So that's mean this very smallest particle cannot be measured the momentum as well as position as exactly simultaneously. Okay, so this failure of that macro particle, the planets, they have all planets revolving around the sun, or for example earth or revolving around the sun. There is a earth is a macro level, so there is a failure in this Heisenberg conceptuary principle. Okay, so it's a mathematical representation. There's a change in position into there's change in momentum that is greater than or equal to h by 4 pi. This formula, we know that the momentum, that's mass into velocity, so that's why there's delta x into here. There's a delta v is greater than or equal to here h pi, there's a 4 pi m. Okay, so simply what we using here, there's simply this relation, nothing but there's a simple relation. Suppose in case of there is a energy and time, the energy and time relation, there is delta E into delta T greater than or equal to h pi, that is a 4 pi. Okay, so whatever that, here there is delta x is nothing but it's a uncertainty position, and delta p is nothing but there is a uncertainty momentum, or there is uncertainty velocity, this uncertainty energy and its uncertainty time. Okay, so this very important of the mathematical relation. The de Broglie and Heisenberg concept significance only for that's a microscopic or very smallest microscopic, or there is a very smallest particle like atoms, ions, electrons, whatever that very smallest particle that is applicable. Okay, okay, thank you. If you like in this video, you can subscribe and share your friends. Thank you very much.